Welcome back. We're in lesson 125. We're going to do some more geometry today. We're going to talk about distance. We remember the definition of distance. The distance between 2 points is the length of the segment that connects the points. Well, now we're going to add to that and say any 2 points that are equal distant from the ends of a segment on the perpendicular bisector of the segment lie on the perpendicular bisector of the segment. So we are going to draw a line. If I can get my little line thing here, I'm gonna kind of give you an illustration of that. So we're going to show we have AB here. That's our line. We have a this is the line that I want to talk about. Let me make it a little bit more centered. There we go. So any 2 points that are equal distance from the ends of a segment lie on the perpendicular bisector of the segment. So basically what that means is that if A, let's call this point C and point D, if from A to C and A to D are congruent, and that doesn't even look like a straight line. It is not going to let me change it either. Yeah, let me straighten it up just a wee bit. There we go. Let's just say that this is congruent to this. If this is congruent to this, and these points are equidistant from one another, centered over point A, then that means that this line is perpendicular to the bisector of this segment. Same thing here. If this line is congruent to this line right here, then that means that B bisects C and D. And that's how you tell if this is in the center of this line by measuring from here to here and from here to here. And if they are the same, then it is indeed in the center, and it is a bisector of that segment CD. Any point that is equally distant from the 2 sides of an angle lies on a ray that is the angle bisector. So that means if I have a point right here and I were to measure from here to here and from here to here, and those were the same distances, then that would be in the center and it would lie along the ray that bisects the angle. Pretty straightforward stuff. It's fairly common sense in proofs and geometry. You're not getting too deep. It's just kind of calling out the obvious sometimes. All right, so if I right eye, that does not sound good. If 2 circles have radii, I'm sitting here going, what in the world? I never said red eye or right eye. That should be radii. My Southern accent sometimes doesn't come across the way that I want it to with my dictation into the computer. So if 2 circles have a radii whose lengths are equal, the circles are congruent circles. So that means that if the radius of this circle is, let's say it's 3 centimeters. If the radius of this circle is 3 centimeters and the radius of this circle is 3 centimeters, then I have 2 congruent circles. That's all you have to have for congruent circles, that the radius has to be the same length, because that defines the circle, is the length of the radius. A tangent to a circle is perpendicular to a radius of the circle at the point of tangency. So all that means is when you have a tangent here, let me put that tangent right there. Okay, and then you have, I'm going to erase this right here, just temporarily. We put this to the center, or about thereabouts. That looks like the center. When you have a radius and a tangent here, the point at which it connects, the tangent is perpendicular to the radius. That's all it's saying. At the point of tangency, it is perpendicular to the radius. It just makes that nice little 90-degree angle to the tangent line with the radius. The lengths of tangent segments intersect at a point outside the circle. All right, the lengths of tangent segments that intersect, I missed that, intersect at a point outside the circle are equal. All right, so all that means is if I have, let me get this line right here, and I'm going to bring it down. Here's my point of tangency here, and I'm going to draw another line right here, turn it into a tangent by making it touch like that. Go back to this one. All right, so this just says that from this point to this, why did it move? Oh, here. From this point here to this point here, where they intersect here, these two sides are going to be congruent. That's all it says. All right, let's look at our last little bit. If the radius, I'm going to get a new radius here. If the radius is perpendicular to a chord. Now we know what a chord is. A chord goes across a circle, just like that. Boom. Right, here is center of our circle. Maybe not. I can see that a lot better when I have my dots on. So here, right about here is the center of my circle. All right, that's much easier. Okay, so center of my circle is here. If the radius is perpendicular to a chord, so let's draw a perpendicular radius right there, then it bisects the chord. So all that means is this side is going to be congruent to this side. Okay. If a radius bisects a chord that is not a diameter, then it is perpendicular to the chord, which just means these are 90-degree angles, right? If the radius is perpendicular, then these are congruent. And if the radius bisects a chord that's not a diameter, then these are 90 degrees and these are perpendicular. So these two work together. And the perpendicular bisector of a chord passes through the center of the circle, which we know the radius goes to the center, at least goes to the center. So all of these kind of say the same thing here. All right. So that is some more, just some logic for your different shapes that we have used so far to date. Just terminology and language and just a way of looking at the shapes geometrically using congruency statements. You can use these congruency statements in your proofs or to figure out your proofs, okay? And that's all we have for lesson 125. We don't even have an example problem because these were all of our examples. All right, and I will see you in lesson 126. We just have 4 more lessons to go. I know you're stoked. I'll see you next time.